Hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. As you know, this is a brand new channel by Unacademy, which is India's largest online learning platform for IIT And on this channel, everything is being taught to you completely in English, so that no student is feeling left behind because of the lack of or because of the extensive usage of Hindi in most of the content available on YouTube. Okay, so our idea is that every student should get fair chance to study their concepts and understand them irrespective of the language that they're comfortable with. So in that note, we have this series, and this is a series that I host for class 11 students. And the topic that we are discussing today is rigid body motion, and today we'll be talking about toppling and some previous year questions. Okay, this is lecture number 13. Before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for IIT JEE Mains and advanced examinations. Now, I myself was All India rank of 447 and All India rank of 192 in the two stages of the IIT JEE exams that I took. Now, I also qualified NTSC Stage 2 as a student, and I was in the top 1% in the NSCP also. Now, in my this experience of my teaching so far, which has been offline, I've been associated with some of the topmost institutes known in the industry, and there I've had a chance of mentoring many students to top ranks and their dream colleges. And now I hope to continue doing that with you guys. So how can you make sure that in this kind of environment your studies go on uninterrupted and you are studying as you should have? And this is one opportunity that you can definitely use. So you can get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators. Then you have live polls and leaderboards where you also have a test series and analysis sessions. So all these benefits ensure that even in this lockdown, your preparation is going on not only smoothly but better than others. So trust me, this is a competitive exam. You need to not only prepare, you need to prepare better than others. The subscription will help you with that. And of course, you have live doubt clearing sessions in with all the Unacademy Plus courses. So these make sure that your doubts are never getting piled up. In all Unacademy Plus courses, every fourth session is supposed to be a live doubt clearing session. So after every three teaching sessions, you have an entire session dedicated to doubts. They may be about theory, they may be about your questions. So as you are moving forward, we don't only make sure that you understand the theory, we also ensure that you have no doubts left at all. Okay, now on top of all these benefits, you also get a chance to study from the topmost educators all across India from the comfort and safety of your home. So this is another huge opportunity that you're getting. This kind of opportunity you wouldn't have even gotten in an offline setup, right? Here you have the chance to study from whoever you want, from some of the real topmost educators, professional experienced people to help you with your IIT JEE success journey. All right. So how do you get the subscription? Very, very easy. First, you need to install the Unacademy app. Once you've done that, you'll need to go to the plus section of the app, select your goal as IITJ, and click on that get subscription button. Now, once you do that, you'll be redirected to the payment page where you can use this code RD Live. So you'll have a box which will say, "Do you have a code?" So that is where you can use this code RD Live, and this code will make sure that you get a 10% off on all your subscription fees. Now you can opt for two kinds of subscriptions. One is a plus subscription, another is an iconic subscription. So I'm sure all of you are aware of the plus subscription. Okay, now what is iconic? So we'll talk about that in a bit. First of all, let me also tell you, when you click on proceed to pay, you also get a lot of no cost EMI options to choose from. So even if this payment feels a little steep to you, then you can divide it, break it into a lot of no cost EMIs that will make sure that you don't feel the burden of this payment. Now, let's talking about iconic subscriptions. So Unacademy also providing you another opportunity now. You can now get the iconic subscription. This subscription will take your ITJ preparation to the next level. So you'll be allotted personal coaches. Then you will attend ITJ workshops on a regular basis. You will receive expert guidelines. You have a study planner. Again, a huge benefit. I think a lot of students struggle with the planning of their studies. So here that is also taken care of. And of course, you have very regular test analysis sessions. So these features will, trust me, take your JEE preparation to the next level. It will definitely make sure that you land up to the best of your potential and closest to your dream ranks and dream colleges. Next, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link so that you can keep receiving all the notifications of all the amazing sessions and lectures happening on this channel. and you're not missing out on anything. All right. So why don't we get started with today's discussion then? So today, as I said, is lecture number 13 of rigid body motion. Today we'll be talking about mostly toppling, and then we will be discussing some really tough issue questions that a lot of students have had their doubts about. So let's get started. So first we'll talk about toppling. So what is toppling? So here is a very good example you can see from this figure. So whenever you apply a force on any object, okay, so imagine whenever suppose you have something like this, and if you're applying a force on this, if you apply a small enough force, then it doesn't actually fall over. If you keep increasing the force, however, beyond a point, this thing will fall over. Now that is called toppling. So what will happen, as you can clearly see from this diagram, so if you see the center of mass, as long as the weight is applying a torque in this direction, so you must be applying a torque in this direction, which will try to topple it like this as shown. If the weight can produce a counter torque which can balance this, then the body doesn't topple. But if you keep pushing it, then you realize that the center of mass's torque keeps on shifting. And if it becomes like this, then you will see that the body will topple. So this is a great picture to visualize that, what is happening. Now, another interesting thing that you will realize is that imagine not every time actually it happens like this, that whenever you apply a small force, it does not start to rise, right? What happens initially is that when you apply a little bit of force, then what is happening is that it does not even tilt a bit, right? Imagine you applied a small amount of force. What happens is that imagine when you did not apply any force, if an object was simply kept like this, right? So, when we draw the FBD of this, okay, so what all kind of forces will you show on this? So first you show the weight, and where do you show the weight? The weight is shown at the center of gravity, right? Okay. So the weight does not act actually at a single point. You will realize that this thing will be constituted of many point masses, correct? So imagine this is constituted of many point masses. Now every point mass will feel a weight or the force of gravity from the earth, right? But what you are showing here is the single point at which the entire force of gravity acting on this entire block can be seen to be acting, okay? So this force that I am representing shows the overall effect of all the gravity forces that all these individual masses are feeling, right? So that is the effective position of the force. Similarly, what happens is, if you talk about the normal reaction, then what you will realize is that the normal reaction will be exerted at all these points, right? So if the normal reaction is exerted at all the points, so what happens when you show this line? So we usually represent normal reaction like this. Okay, so this is how we usually represent normal reaction. Why are we doing this? This is essentially a single force which is representing the average position of all these small normal reactions that are getting applied at all the points of the surface. So that is what you need to remember. That is what is happening. This n that you are showing here, it is the average position of all these forces. Now, all these forces under normal circumstances would be equally divided, evenly distributed, correct? So that is why the average position would lie right in the middle. And that is why the normal reaction is usually shown right in the middle, perfectly pointing vertically up, and it obviously will pass through the CM because the average position or the CM also because of the symmetry lies on that line, right? Now, imagine what happens if I apply a force as shown here. So imagine if you applied an external force here. Now, what that does is that it will try to rotate this object like this. So now, when the object was just placed on the surface, we realized that all these points were pressing the ground equally. So since they were pressing the ground equally, they were getting the normal reaction also, which was evenly distributed. Now, the moment this happens, you will realize the moment you apply this force, now because the body has a tendency of turning like this, so you will realize that the pressure on this side that the body will apply on the surface. Okay, imagine that the pressure that this object is applying on the ground is higher on one side and lower on one another side, because this body is trying to turn like this. So it ends up pushing this part of the surface with a greater force than this. Okay. So what happens is, what you realize is that the average position of the normal reactions begins to shift. Okay. So that is what is happening. So what will happen is that here in the second case, you will realize that this guy will feel pushed the hardest than this guy. And this is what will start happening. The normal reaction will no longer be evenly distributed. Okay. This force will eventually actually start being the highest at one point and start to lower towards the other end, because of which the average position of this force of normal reaction. Hello Varun, how are you? Hello Rajesh, hi S Pandey. So now, as a result of this, what will happen? So I hope you can visualize this. I hope you can understand what is happening. So the body is pushing the ground harder on one side, and it is applying a lesser force on the other side. As a result, the effective position of this force will in fact shift. Okay, so it just shifts, and this is what your new normal reaction will pass from. Okay, so that is what is happening. And now this shifted n is actually what is balancing the torque of this force F. So if you had to evaluate and analyze the equilibrium of this body. So as I said, okay, so let's take an example of this. Okay, so this is a good sanitizer bottle. Okay, so if imagine I applied a small force here. If I applied a small force here, I don't see this tilting. So what is happening to the torque of this? Who is balancing the torque of this? So what we can do is, when if I analyze the situation in here, right? So let's say I applied the force somewhere here, anywhere I may have applied the force. So what is happening is that this body is still in equilibrium. Okay. If the body is in both translatory and rotatory equilibriums, then what I can realize is Sabrish Kumar says, "Sir, my school calls me for exam tomorrow physically." Ouch. Okay, Sabrish, that is hard. Well, I hope you are well prepared, and I wish you best of luck. And I don't know what else to say. Hmm. That is going to be tough. Be safe and do well. Okay, that is all I can say from my side. So what I can say is, if this object, if the object is in equilibrium, is in equilibrium under the force, under the action of capital F. Now you realize, so it will have both kind of equilibrium, both translatory and rotatory, right? You can see here. When I'm applying a force, neither is this object translating nor is this object rotating, right? So I have to write conditions for both the translatory equilibrium and the rotatory equilibrium, correct? Ananya ji says, "Sir, before starting with your AC playlist, do I need to watch anything else?" So, of course, you will need to watch maybe a little bit of. You have to have knowledge of capacitors and inductors. Okay, so you have to have the basic understanding of what capacitors are and inductors are. So that will definitely help. Second thing that will help you analyze AC better is if you have revised your waves, because we use phasors in our analysis of AC. So phasors we also studied in SHM and waves. So if you can quickly revise your SHM and waves, that will help you understand the AC analysis a bit easier. Okay, so that is what I can tell you, Ananya. Okay. Now, all I can say is that if the object is in equilibrium under the action of F, then let's write the equations. So let's see who is balancing what and how is the body in equilibrium. So there must be another force which will be the force of friction, correct? There has to be a force which is essentially balancing the horizontal force. So there must be some friction acting. Let's draw that friction like this. Let's imagine the ground is also providing a force of friction. Okay, so that is acting like this. So now for translatory equilibrium, what all can I say? For translatory equilibrium, I can say that one n must be equal to mg. Okay, that will be your first equation. And capital F must be equal to small f. That will be your second equation. Right? I hope everybody understands that to balance the forces in the y direction, the normal reaction must have had a magnitude of equal to mg. Similarly, for balancing the horizontal forces, the force capital F must be getting balanced by the force of friction. Okay. So I hope everybody is following me so far. So this is the conditions for translatory equilibrium. Now, how about the rotatory equilibrium? So for rotatory equilibrium, you could have taken talks about different points. So what I will do is that I will take the talks about this point. Let's take the talks about this point O. So what is O? I'll tell you. It's called this point O. So this is where the mg is crossing the bottom of the surface. Okay. Good evening to you, Amod Kumar. How are you? Okay, so I can take torques about O. So about O, you realize friction and mg cannot produce any torque. Okay, the only torques that are getting produced are due to capital F and due to my normal reaction N. Okay, so let's still keep calling it N only because its value will just change. It's just shifted. It's still N. Okay, so let's say that this shifted by some distance x. Okay, if this shifted by some distance x upon the application of this force, so we can delete this. This is no longer acting now, and this is the situation. Only my n, which has gotten shifted, is acting. Okay. So now I can say for rotatory equilibrium, if I take torques about O, then what am I getting? Let's see. So for rotatory equilibrium, right? Taking torques about O. Let's see what we get. We will get that whatever the torque this guy is producing a clockwise torque, right? If this is acting at a height h, then this clockwise torque would be balanced by the anti-clockwise torque that the n would be providing, correct? So the equation that I can write is F times h must be equal to n times x. Now this will be my equation number 3, right? Now what I can do is that I can substitute the value of n as mg from equation number 1. So let's see what we will get. We can in fact calculate by what amount did the n shift. Okay. So I can say from 1 and 3, what I can say is that x would be equal to f times h over mg. Okay. So that is what is happening. As you keep on increasing your f, the n goes on shifting. Okay. And that is what you realize. That is what you realize eventually. What is happening is that as you are increasing your f, or you're increasing your height, by the way, so the n starts to shift. Initially it was like this, then it shifts here, and if you keep on increasing, it shifts here. But what you realize is that it cannot shift beyond this. Why? N is a contact force. Hi AP, how are you? N is a contact force. It cannot go beyond the surface of the object, correct? So since this is a contact force, it can never go out of the surface. It has to pass through the point of contact. So the maximum that the n can shift is this dimension. If I call these dimensions, so let's give some names to these dimensions. So let's call this breadth b, and this is the length of the rectangular looking thing. Okay. So you realize if this was b, then you realize that x max, how much is the maximum that your x can shift? Now since x max equals b by 2, so therefore if f is less than equal to mg b over 2h, so if that is the condition, so you realize for this x will remain less than equal to b by 2, right? So for that, for up to this amount, the torque due to F can be balanced by N. N would shift, try to balance the torque due to F. Now, what happens if I increase it further? What happens if I increase it further? So let's write this. So for f less than this, the n can shift its position, can shift its position and balance the torque of capital F. However, the moment capital F exceeds this value, now you realize n has no more space to shift. So n cannot produce a torque which is greater than n into b by 2. Correct? So if F is able to produce more torque than that, then you see the object topple. So let's see. Let's see the example here. So imagine if I applied a small amount of force, if I kept on increasing the force, if I kept on increasing the force, so n has shifted, n is going towards the bottom, okay, and beyond a point, it just topples, okay, so this will just topple. Beyond a point, it just goes on and gets toppled. So that is what is happening. That is what is happening. That is what you need to understand. So I can say, however, however, if F is greater than mg by 2h, then it's a rotatory torque. Okay, so I don't need to write rotatory torque. It is understood, I think. It will be torque. Torque would be rotatory, or I can just simply say its torque cannot be balanced. Then its torque cannot be balanced. Okay, and the body topples. Now that is what toppling is. When the body cannot hold its rotatory equilibrium and goes on and falls off. Okay, so that is what you call toppling. Okay. now now there is another way of analyzing this. There is another way of analyzing this. Okay. And let's see. If I know this, then what do I also know? So typically every question in IIT is based on the fact they ask you whether does the object topple first or does it slide first. Hello, Mahiji, that's all right. That's all right. But make sure that you watch the recording. Okay. So any typical question, okay, typical questions on toppling. So typical questions on toppling, what they do is ask the conditions for toppling happening, toppling to happen before slipping, okay, and vice versa. So they will ask you whether is toppling happening before or slipping happening before. So we already calculated the condition for toppling. So I can say since for toppling, what is the condition that we just found it was that F should be less than equal to or should be greater than, we just greater than mg. Let's call b by 2 to be x max over h. Okay, so this is the condition for toppling to happen. And for slipping, what I can say is for slipping, if f becomes greater than mu mg, which is the limiting friction. So I hope now you need to remember what was balancing, what was maintaining uh, the translatory equilibrium in the x direction. The force capital F was getting balanced by friction. So if you keep on increasing capital F, if you keep on increasing capital F, then the required friction to avoid the slipping will also increase. However, this friction can only become equal to limiting friction at best, right? So if your capital F exceeds the value of limiting friction, then the object will begin to slide. So that is why I can say that this is the condition for toppling, this is the condition for slipping. So whichever is less, that will happen first. Okay? So that is how you will approach this kind of question. Okay. So therefore, if so Let's call this F toppling, and let's call this F of slipping. So if F toppling is less than F of slipping, then toppling happens first and vice versa. This is how you could have answered this, right? Now, there is another way to approach this kind of problem. Okay, so as I said, one is that you consider the shifting of the N, the normal reaction, right? Another way, alternately, what you could have done was, as I've shown in the figure in the introduction. Hello, Ratsi, how are you? As I've shown in the introduction figure. So when the object is becoming like this, the object is becoming like this. When will toppling happen? When will toppling happen? Toppling will happen if you're asked the angle, if you're simply asked the angle at which the object will topple. Okay, so if you're lifting it like this, so for calculating the angle, what you can say is that if the angle is such that the mg passes right from this point, now any angle greater than that would cause the object to topple. So for instance, when you see here, so when I even make it like this, so here mg is still passing through this. Okay, so assuming that it has some center of mass here, so as long as mg is passing within this range, the object will not topple. So here, so the moment imagine the mg becomes like this, so that it starts to pass from here, from outside the body, you will realize now this will topple. Okay, so now this will topple. So that is an alternate way of finding the angle by which if I tilt it, then the toppling should happen. So take torques about this point. The advantage is when you're taking talks about this point, then you will realize if I just told you that thing has been left at an angle, and will it topple or not? Okay, so assuming that you're not applying the external force right now. So this is an alternate kind of a scenario that is asked usually. Okay. So you're just tilting it. You just tilted it and you left it. So I've been asked, if I tilt it and leave it, will it topple or will it come back? So I need to analyze whether the torque due to the gravitational force is trying to restore it or trying to move it further. Okay. If I can do that, then I can solve this. Okay. Now let's take up some questions that have been asked previously in JEE. Okay, so this is another example. So let's first go through one example and let's see how this works. Okay, so this question says a uniform cylinder of height h and a radius r is placed on its circular face on a rough inclined plane, and the inclination of the plane to the horizontal is gradually increased. Now, if mu is the coefficient of friction, then under what conditions will the cylinder A slide before toppling and B topple before slipping? Okay. You have to find the conditions. If you can find the condition for one, then obviously the other would be the reverse of that. Okay. So under what conditions? Find the conditions under which the sliding will happen before toppling, and also if under what conditions will toppling happen before sliding. Why don't you guys try this? So what do you think is happening? This is the kind of case where I was saying that this is a case in which you don't require an F external to cause the toppling. The weight itself will cause the toppling. Okay. So here also you will realize. So if you took talks about this, then mg sine theta is trying to provide a counterclockwise torque. So for to be able to balance that, the end starts to shift towards this end. Okay, as you can see in the FBD shown, right? The maximum that the end can shift is to the boundary. If the end can balance the torque of mg at the boundary, then it won't topple, otherwise it will. Okay, so there's your hint. Now find me the condition. Okay, find me the condition for which toppling happens before sliding and for which sliding happens before toppling. Okay, so give it a try. And today we are going to discuss the most controversial questions that have been ever asked in JEE. Okay, some questions which have left people very confused. Okay, and a lot of people I think had requested me to take up and discuss those questions. If you remember, there was one question which was asked in 2016. So that was a controversial one. And then there was another question that was asked in 2017. So there, I if as far as I can remember, two questions have been really controversial that have been asked in JEE Advanced, and about which they had a lot of problems. Okay, so S Pandey is trying. Good to know. Okay, okay, let's see. So hint, you already know the condition for slipping. Okay, I hope I know the condition for slipping. Okay. Okay, let's see some answers. Let's see. Let's see. So hint is you find the force required to cause toppling, you find the force required to cause slipping, and that is how you can do it. So try and give me an answer. Let's see. So any ideas, people, how you would have done this? Think about this. Think about this. Okay, do you want me to go ahead and solve this? Okay, so why don't I tell you? Because this is the first question that you're doing on toppling. So first of all, let's see. Do we already know what is the condition for slipping? I hope you remember. The condition for slipping is that tan theta is greater than mu. If tan theta becomes greater than mu, then definitely slipping will happen, right? This you should remember. You would have done this a lot of times. Now let's try to find condition for toppling. The condition for toppling would be condition for toppling. What will that be? We will realize that the mg sine theta is providing a torque which is trying to rotate it. Mg cos theta and friction about this point do not produce any torque. This is the FBD. And the maximum that the N can shift was still here. Imagine the N has shifted to here. Now, if the torque of mg sine theta at this position becomes greater than the torque that N can provide, then the toppling will happen, correct? So can I say that mg sine theta into h over 2, which is the torque due to mg sine theta, should be greater than the torque due to N. Should be N times R, and N is equal to mg cos theta, right? So I can rewrite this as mg sine theta to mu by 2. Okay, so there was no mu. In fact, there was some h. Becomes greater than mg cos theta times r. Okay, so here I am getting the condition as tan theta greater than 2r over h. Okay, so obviously, you will need to see which one is greater. So I can say if mu is greater than 2r over h, then what I can say? Toppling happens first, correct? And vice versa. Okay, I hope that is clear. That is very, very simple. All you need to figure out is that when as you keep on increasing the angle, which of the condition would come first? Okay, will the condition for toppling happen first, or will the condition for slipping happen first? So if mu was greater than 2r over h, then as you increase the angle, then you will realize that tan theta would become greater than 2r over h first, and it will still be less than mu. Okay, so in this kind of case, toppling will definitely happen first. And if it was the other way around, then a slipping would have happened first. So this is the required condition. Okay, I hope everybody's feeling comfortable with this. Okay. Now comes the important part of today's discussion. This is going to be really, really tough and interesting. So now we will talk about the previous year questions. And here, when I say PYQs, I am going to talk about some advanced questions. Let's see what kind of questions has JEE Advanced asked us on a rotation. These are some of the toughest questions that have been asked, right? The toughest questions are asked from rotation. So let's take a look at those. So, okay, so we'll start with something very simple. Okay, so we'll start with, in fact, a question which is asked in AI triple E. AI triple E used to be what you call your mains. Okay, so this is what was asked by AI triple E in 2005. So this says a T-shaped object with dimensions shown in the figure is lying on a smooth floor. Correct? Let's enlarge it so that you guys can see it better. So a T-shaped object with dimensions shown in the figure is lying on a smooth floor, and a force capital F vector is applied at a point P parallel to the line AB, such that the object has only translational motion. Hello, Tanya, how are you? Such that the object has only translational motion without rotation. So pay attention to this. To find the location of point P. So any ideas how you would have done that? With respect to C, by the way, you have to say. With respect to C, where will the point lie? Think about it. Think about it. This is in fact an easy one. This is a very, very easy one. In fact. Hmm. Let's see if you can figure this out. Okay, so we are starting with some easy ones, then we will take on some really challenging problems. So when does it happen? When does it happen that you apply a force and the object begins translatory motion without rotatory motion? So this is a general motion problem. Okay. Okay. So S Pandey says D. Okay. So I'll tell you what. I'll tell you what. The condition for this kind of motion would be that if you apply the force at the center of mass itself, so that will be the condition. So any object you have, if you have the center of mass here, C, if you applied a force which is directly in line with this, so what would have happened was that this kind of force will not provide any torque about the center of mass. Okay, so such a force can only start a translatory motion. For instance, you can notice here, if I apply a force here, which is right at the center, then you realize that this only starts to translate. It just moves forward. If I apply a force near the end, then you will see that it moves forward as well as it rotated, right? So that is the trick towards solving this. To cause such a motion, to cause such a motion, the F vector should be or should act along the CM. Okay, so that is the trick of solving this. Yes, I think most of you are correct. Now you realize the shape that was given to me was this rod. So rod has two parts. Okay, rod has two parts. One has a center of mass here, one has a center of mass here. And I think both are identical. Yeah. Okay, so no, both are not identical in fact. Okay, so this was a tricky question. Okay, this was a slightly tricky question. It does not say that both have the same mass. Hmm. T-shaped object with dimensions shown, lying on a smooth floor. So here, you needed to pay attention to one thing. What is that? If the mass of this is m, the mass of this would be 2m. Agreed. Why? Why? Because the length of this was L and the length of this was 2L. So the mass of AB rod was M, then the mass of the rod which is lying below would be 2M. Right. So where does the center mass of M and 2M lie? Let's see if it lies from here at a distance x, then you will realize that x would be equal to this entire length would be L. Okay. M into L over 3M. That is L by 3. So the total distance from point C, this would have been B would have been L plus L by 3. So that would be 4L by 3 back. 4L by 3 is the correct answer, option number A. So yes, if you did not pay attention that the length here was 2L, then you would have gotten 3 by 2L. Okay, but you need to be careful about this. Okay, so that is also an interesting problem. Now I hope you will remember. Always pay attention to the dimensions also. Okay. All right. Now let's move on. Let's move on. Now this is a very interesting problem. No, it was 4L by 3, not 2L by 3 AP. It was 4L by 3. Okay. In fact, 2L by 3 is not even any of the options. 2L by 3 is not even any of the options. What are you guys saying? So the options are 4L by 3, L, 3L by 4, and 3L by 2. So please note that they had this option to confuse you. So that is what people who are making the papers do. They do like to confuse you. Correct answer was 4L by 3. Okay, now is another question that was asked in JEE 2011. Okay, again, this is a very, very nice question. This says a thin ring of mass 2 kg and radius zero point 0.5 is rolling without slipping on a horizontal plane with a velocity of 1 meter per second. Now, a small ball of mass zero point 0.1 moving with a velocity of 20 meter per second in the opposite direction hits the ring at a height of 0.75 and goes vertically up with a velocity of 10, okay, immediately after the collision. Now, option A says the ring has pure rotation about its stationary CM. Okay, so guys, you should be paying attention. Okay, we have moved on to the next question. Yes. So ring has pure rotation about its stationary CM. Option B says that ring comes to a complete stop. Option C says that the friction between the ring and the ground is to the left. And option D says there is no friction between the ring and the ground. Okay, so what do you think must be happening here? Okay, so try this, try this. Let's see if you can get this right. Okay. Let's see what will happen. This is a very tricky question, by the way. It does not appear that tough, but this is very tricky. Is I think the only thing that is missing is they should have mentioned whether the ground has friction or not. I think we'll assume that the ground has friction. The ground is not smooth. Let's assume that. Yeah, I'm surprised that they did not mention that. So that is so weird. Okay, so try this. Try this. Let's see. This is another interesting problem. We'll figure this out. Till then, let me help myself with some water. So think about this. Think about this. What will happen? What do you think will happen? Now again, So JEE likes asking you quite tough questions. Okay. So if you are not solving the tough problems, trust me, this is not something that you'll be able to solve. This is not something that you will be able to solve. You haven't solved tough questions. Okay. So let's see how you would have solved this. Okay. Think about this. Think about this. Do think about this. So Sai Teja is saying, sir, but understanding. What Sai Teja? Not understanding. Please once again request. So okay. So what are you not understanding? This is the question that was asked in JEE 2011. The situation is a thin ring of mass 2 kg and a radius zero point 0.5 is rolling without slipping. So read the question. This was rolling without slipping on a horizontal surface. So initially you had a ring which was moving like this. Okay, happily moving with 1 meter per second. It was happily rolling without slipping like this. Okay, and now a small ball of mass zero point 0.1 moving with a speed of 20 meter per second in the opposite direction. So here is a ball which comes moving in the opposite direction. It ends up hitting this moving ring here and then it goes up here. Okay, it hits the ring and then goes vertically upwards. That is what has been told to you. Now, if this is the case, then what will happen immediately after this collision? What will happen immediately after this collision? Option A says that the ring will has pure rotation about its cm. Option B says that the ring comes to a complete stop. Option number C says that the friction between the ring and the ground is to the left, and option D says that there is no friction the ring and the ground. So what do you think will be the correct option? Again, very tricky problem. Not the standard problems that you guys see. This will involve a very tricky concept. Okay, so try about it. Try about it. So how do you approach such kind of problems, including collision? Including collision, how do you approach this problem? Now the tricky part here is that let me give you a hint. Let me give you a hint. This is the tricky part here. In most of the problems of your collision, the ground was supposed to be frictionless. They have not mentioned if the ground is frictionless or not. Okay, you realize the rolling motion could have happened on a frictionless ground also. Anyhow, if I assume that the ground has friction, then also I should have been told the friction coefficient. Should have been told the friction coefficient. Let me just check this question. Till then, you guys try. So D. Okay, may be correct, or you have to find the best of the two options. So let's assume that there is no friction between the ring and the ground, because otherwise we won't have any other way of solving it. So I'll tell you why. I'll tell you why I'm saying this. So you will realize this in this kind of a case, the problem is that since the ball is getting a momentum in this direction, so the ball received an impulse in the j direction, which will mean that the ring will also receive an impulse like this, which would imply that the normal reaction between the ring and the ground would have become impulsive during the collision. If the normal reaction becomes impulsive, then you must realize that the friction also becomes impulsive. So this is a case C getting in difficult way. Okay, this is the case where there is an impulsive friction coming from the ground. Okay, but what can I say about that impulsive friction? Okay, so let's analyze the situation. Maybe the impulsive friction will not come. Okay, there may be a special case where you don't need the impulsive friction. Okay, let's try and analyze. Okay, so there may be two, three cases. So this is a very tricky question. That is what I was telling you guys. This is a very, very tricky question. So think about this. Think about this. So here, there could have been impulsive friction. There is the hint that I'll tell you. That is what makes this problem really, really tough. If you were told that there is no friction on the ground, then you didn't have any trouble, right? But if there was friction, then you could have had impulse or due to friction also. And the weird part is that you haven't been told the mu. So that leads me to believe, since mu has not been told, since mu has not been told, so D must be correct. There must be no friction between the ring and the ground. Okay, so that is one thing that I can just logically conclude. Otherwise, to analyze the situation, they should have given me the value of coefficient of friction. Okay. So I hope you know that whenever n becomes impulsive, then impulse due to friction. Okay, you should know this. Impulse due to friction is mu times impulse due to n. Okay, I hope you guys know this. Though you never solve any problems for impulsive friction, right? That is why you don't know this. Because a lot of students, they never solve any problem on impulsive friction. Okay. So let's see. Let us try to analyze this situation. Now, the problem that I have is, I'll tell you the issues that I'll have. Can I directly apply momentum conservation here? Can I directly apply momentum conservation? Sir, if such type problems given in advance, there is no time to do. We can't think the difficulty level of question. What you do? Okay, so first of all, Sai Teja, don't worry. If you have practiced tougher problems, you can think about this. You can think about this. There is ample time. Don't worry. There is ample time in advance. In advance, they give you a lot of time. They ask you roughly 15 to 18 questions in 1 hour. So you do have like 3 minutes at least to think about this problem, three and a half minutes. And if you can solve some problems even earlier, then you may stretch the time of this question up to 4 minutes also. So if you have a lot of practice, then you will be able to solve this. So don't worry about it. So let me tell you what I can do is. So first of all, the problem here is that I don't know if friction is going to be acting or not. Why? Because as I told you, in this kind of collision, the n is impulsive. If the n is impulsive, then the friction could have been impulsive. So if I could have had an impulse due to friction, then I cannot apply momentum conservation. Please note, I cannot apply momentum conservation. Why? Because I could have had an impulse due to friction. Okay, I could have had an impulse due to friction. Now, let's try and first imagine if the ground was frictionless. Let's try and analyze then, and then we will see how to do it. If ground was frictionless, so that is the case that I can analyze easily, and then we will see the difference. Okay, so that is what you do. If you don't know whether there is friction or not, now even if there is friction, we are not certain that the friction will come into play, right? If there is a requirement for friction to come into play, then it will come into play. Even otherwise, if there is no requirement, even if there is friction, it might not come into play. So just to check that, I will start by assumption that the ground is frictionless. Okay. So then you will realize now I can apply momentum conservation. Okay. And I can also see the impulses that this guy is getting. Okay. So using linear momentum conservation in the x direction. So this had some speed of 1 meter per second. So this is a very, very interesting problem, very, very tricky problem. This had a speed of 20 meter per second. and this had a mass of 2 kg, this had a mass of zero point 0.1. This guy has a mass of zero point 0.1, this guy has a mass of 2 kg. So let's apply momentum conservation. If the ground was frictionless, then I don't have to worry about impulsive friction. Then I could have applied momentum conservation in the x direction. Okay. Not in the y direction still. Why? Because in the y direction, you could have had an impulse due to the normal reaction, which would have been an external impulse. So I can still, however, applying momentum conservation in x. What I'll see is initially the total momentum was 2 into 1, okay, and minus 20 into zero point 0.1. Okay, this should be equal to finally 2 into v. So let's assume that this guy is moving with v after the collision. So you will realize that the initial total momentum was 0 in the x direction. So from here, what I'm getting is v equals 0. Okay. So if this was the case, okay, is v 0? Yeah, this was 0.1. V is coming out to be 0. So if the ground was frictionless, then the cylinder would have stopped. Now let's see what happens to omega. Again, we will continue with this assumption that the ground is frictionless. Then what I will do is taking torques about the CM. I will take the torques about the CM. Why am I doing that? So that even if N is impulsive, there is torque due to the impulsive N, I can ignore that. Okay. The only angular impulse I will have is due to this collision. So let's try and calculate the impulse. So the impulse that this C will receive, J vector, that would be one. It will receive an impulse of 20 into zero point 0.1 I cap in the minus I direction. Okay, and then it will receive an impulse of, it was going up by 10. Okay, so it will receive an impulse of in the downward direction again, 10 into zero point 0.1 A cap. So the impulse that this ring is receiving has two components, right? One in this direction, which I am getting as 2, and one in this direction, which I am getting as 1. Okay. Now these impulses will provide an angular impulse also. Okay, so let's calculate the angular impulse, and then we will apply the angular impulse angular momentum theorem. Okay. So assuming that initially it was rotating with some omega naught, and finally with some omega. Then let's see what would have happened due to this impulse. Okay, so can I say, so this would be 0.25, and how about this vertical distance? So let's try and use some geometry. Let's draw the diagram here only. So I have this, I have this. So this is R. This here is R by 2, right? Because R was 0.5. So what will this be? This in fact would be, can I say that this theta is 30 degrees? The sine of theta is 1 by 2. So this is R cos theta. This will be root R by 2. Okay. So now let's try and find the angular impulse. Therefore, angular impulse about C. How much will that be? That will be, so this is 2 into 0.25. This is a clockwise impulse, angular impulse. Okay, and then you have a counterclockwise impulse. So minus you would have had 1 to 1 into root 3 by 4. Okay, because R was 0.5. And this should have been equal to mr square, which would have been 2 into r square, which would have been 1 by 4 times omega naught. Omega naught again would have been 1 by V by R will be 2 minus M R square times omega. Okay, so angular impulse would be equal to change in angular momentum. Change in angular momentum would be in fact this minus this. Okay, so this is how you would have gone about this. This is how you would have gone about this. What we are trying to see is that what does this impulse do? This impulse is making the velocity zero if there was no impulse due to friction. And then what is it trying to do to the omega? So that is what I am trying to say. If friction was not there, so what kind of impulse am I getting? So now let's see what I have is okay. So 1 by 2 minus root 3 by 4, 1 by 2 equals, and this is 1 by 2, so it is visible, omega by 2 minus 1. What you're getting is omega equals 3 by 2 minus root. So what you realize is you still have a positive omega. So you still have a positive omega. If you still have a positive omega, then what happens is that this guy has a tendency. This guy has a tendency of slipping backward. So if this has a tendency of slipping backward, then you would have had a frictional impulse which would have been towards left. Okay, so friction between the ring and the ground is to the left. Now the pure ring has pure rotation about the CM. So that I can't really say because now I'll have to take the impulse due to friction also. Okay. So I think I will have to mark C. I will have to mark C. Okay, because without knowing the coefficient of friction, I can't say the other things. So this is a tough question. Okay, so let's just once check it out because I'm surprised that they asked this. Okay. Let me just check once if the question we have is absolutely correct. Okay, very interesting problem again. So IITs would like to surprise you. Okay, they will give you surprising questions like this. Okay, so be very careful. Okay, so why don't you guys go through this once and let me just check that this answer is correct. This question is correct or not. Seems to be a very tricky problem. Okay. So yes. I think this would be the only answer. The question seems correct. This was the question. It turns out it is really tricky. Wow. This is a very tricky situation. Okay. So yes, C is the only option correct. You would have had an impulse. You would have had an impulse. Now, because of that impulse, this result becomes wrong. Okay, this result becomes wrong. Why? Because if there was an impulse due to friction also, then this would have retained its velocity. Okay, it would have retained its velocity. It wouldn't have the velocity wouldn't have come to zero. So this becomes wrong. If this becomes wrong, then this obviously becomes wrong. And this of course becomes wrong. So C is the correct answer, but you had to analyze it a lot. Okay, you had to imagine. You have to imagine that there was no friction, analyze the situations with that, and then what we realize is that yes, the v becomes zero. If there was no friction, v would have become zero, but then omega would have remained. So that cannot happen. That cannot happen. So if that means there was slipping, and since the n was impulsive, since the n here would have been impulsive, so there could have been impulsive friction. So again, as I said, a very very tricky problem. Usually, I remember when I was hosting that Pathfinder session, then people were saying, "Sir, this is such a waste of time. Why are you discussing such difficult problems?" So, have you otherwise ever seen a question with impulsive friction in any of your standard textbooks? Tell me. In any of your standard textbooks, you won't find a question on impulsive friction. Here you have a question on impulsive friction where the n has become impulsive, and that too with rotation. This is a very, very tough situation to analyze. Okay. Yes, I hope you do. You must realize that is why I discuss these tough problems. Okay, because I want you to get out of your comfort zone, get out of the standard discussion that you're used to. Go and think some more because IITs are asking these kind of questions. Okay, so that is why I wanted to include this. This is a very, very interesting, very tough problem to approach. If you don't know the concept of impulsive friction, if you do not know, then you could have jumped to this result. Okay, this result, this wrong result, you could have jumped to. Imagine. Okay, so I hope now you understand. Now let's take a look at again one of the most terrorizing questions that has been asked ever, and to my surprise, uh, I think I in fact when I was trying to find this question, so I was googling this question, so I came across a lot of solutions that people have come out, and none of them were correct. None of them were correct. So there are many solutions available online for this question, and trust me, at least I went through like three, four solutions, and all of them were wrong. Okay, and those are the solutions that have like uh, thousands of views on YouTube. Okay, there were some solutions which had around 100K plus views. So there were two, three solutions which had 100K plus views. People seem so convinced with the solution, but the solution is wrong. Let me tell you. So, what is this question all about? So, let's see. This is one of the most controversial questions to be ever asked in the IIT JEE exam because a lot of students did not know what hit them when they saw this question. So, let's take a look at this question. This is the famous JEE Advanced 2016 question. Today, I'll tell you how to solve this correctly. So IIT should not have asked this question. IIT should not have asked this question. This is out of syllabus. I'll tell you why this is out of syllabus. Diagram not understanding. Okay, so let me get it bigger. This is the question that was asked in JEE Advanced 2016. Okay, this is the exact. I have taken this. I have taken this screenshot from the official site. From the official site of JEE Advanced, from their previous year papers, I have taken this screenshot. Okay, this is what is available on the official site of IIT. Now, this is the question. The question says two thin circular discs of mass m and 4m. So this is a disc which has mass m. Okay, so let's take a look. This has mass m. This is a disc that has mass 4m. They have radii of a and 2a respectively. Okay. So shorts guy, what does he say? Sir, my friend went to the Bab batch in whole of Hyderabad. I am still in second batch. Okay, so don't worry about it. Don't worry about it. That's all right. That's all right. That doesn't matter. At the end of the day, it's your hard work that will matter. Trust me. Forget about all this. Don't pay too much attention to this shorts guy. Let's talk about this problem first of all, and let's see how to solve this correctly. Because trust me, on the internet, all the solutions that I saw which are available on the internet are wrong. You'll be surprised. You'll be surprised that people are putting up solutions and they're putting up the wrong solutions. Okay. Why? Because they don't realize something very, very important about this question. Okay, and I'll tell you what that is. So let's take a look at the question. This question says that two thin circular discs of mass m and 4m having radii of a and 2a respectively are rigidly fixed by a massless rigid rod of length L, which has been shown. So this is a rod by which these two discs are attached to each other. Okay. Third did BTech lessons and intermediate chapters are same. Okay, so no, not really. First year BTech lessons may be very similar to your intermediate topics, but then their level would be very different. The kind of maths that you'll be using there would be very difficult. Okay, so not really the same level. Okay, same topics maybe, but the level would be very different. Okay. What happened, shorts guy? So have you seen ever the solution of this? I think 2-3 people had asked me to discuss the solution of this, right? That is what we are going to be doing today. Now, this says this assembly is laid on a firm and flat surface and set rolling without slipping on the surface so that the angular speed on about the axis of the rod is omega. So imagine this is the rod and this is rotating about its axis with some omega. Okay, this is what is happening. Okay, now you have been told that the angular momentum of the entire assembly, so please note what is it saying. Angular momentum of the entire assembly about O is L vector. Where is O? Here is your O. So the angular momentum of the entire assembly about point O is L vector. You can see the figure. Which of the following statements is true now? Okay, so I hope you guys. There a YouTuber named TB is from UK did this problem, very tricky problem. Yes, and that is what I was referring to. The solution given by TBs is wrong. Okay, shorts guy, you'll be surprised to know that the solution that yes, and that solution is wrong. That solution is wrong. There was another solution that I saw that is also wrong. Now, why am I saying this? And why am I so confident in saying that the solution that they have done is wrong and the solution that I will show you is correct? Is because if you notice here, what is the answer that was given officially? Now, take a look at this. Take a look at the answer that IITs officially gave. Yes, shorts guy, you'll be surprised to know that a lot of solutions that are there to this problem online. That's what I was saying. I was trying to find the question, I was trying to find the diagram and everything. So I also found a lot of solutions online, and all of them, most of them were wrong. Yeah. Now, why I'm saying is that the solution that I'll present to you is correct is because you pay attention to this. What is the official answer key say? It says A or A and C. Or A and C. Why does it say A or A and C? So the answer, the solution that TBS has given is TBS has given this and this, A and C both. Now, why did IIT say A or A and C? Why is this also correct? If you mark A also, then that is also correct. Why do you think that is? Because C is not actually correct. Because C is not completely correct. C is only partially correct. Only partially correct. And that is the trick that TBS has missed, and that is the trick that a lot of people on YouTube has missed. That they did not realize that C is only partially correct. C has another term which they did not pay attention to. So let's talk about this now. Let's talk about the first option. What does the first option ask us? The first question is saying the center of mass of the assembly rotates about the z-axis with an angular velocity of omega by 5. Okay. So what is happening is that this thing is rolling and rotating like this. So it is moving like this. Okay, something like this. Imagine this is the pen. Okay, imagine this part of the pen was not there. This part of the pen was not there. It starts from here somewhere. So what is happening is that this guy is rolling like this and rotating like this. Correct? Correct. So I want to find out the time in which the CM will complete one entire rotation. So let's try and see what is the time in which the CM would move like this and come back here. Okay. Now when the CM, I was so involved, she said, but now it's wrong. Okay. So let's see. When the CM completes one round, so the entire assembly has rotated like this, correct? The entire assembly has rotated like this. So if I can find the time in which the entire assembly is rotating, then I can find out the frequency of, or the omega, angular speed also of, in which the CM is rotating. Okay. So let's see how I can calculate that. So can I say, let's focus on this point. This point is rotating in a radius like this. So there are two, three ways of getting this answer, by the way. The first answer can be gotten through two, three ways. This is the method that I find the simplest. So now you will know that this wheel, when it is rotating, in one rotation of this wheel, how much distance does it travel? It will travel a distance of, forward distance of 2 pi small a, correct? So if this is L, and let's say if this is X, let's say that this is some X. So let's call this X. Now can I find the distance X? Of course I can. I know L, I know A. So let's call this some A, and let's call this B, and let's call this some C. So let's take a look at triangle OAB. So in triangle OAB, what I will realize that since this is 90 degree, this is 90 degree, I can say x square would be equal to L square plus A square. Right. So x square becomes, L was a root of 24a, 24a square plus a square. So from here I'm getting x equals 5a. Right, I've got x equals 5a. Now let's consider it takes time t to complete this one circle. If it takes time t to complete this one circle, so in this one circle, what is the distance that it is traveling? What is the distance that it is traveling? Or let's say, so you can do it in any which way you would like. Okay. So what is the distance traveled? The distance traveled is, in one circle, can I say that the distance traveled is the length of the path, length, or I can say the distance traveled, distance covered in one revolution by the bottommost point, by the bottommost point. How much will that be? That will be 2 pi x. So that is in pi a. Correct. Now let's also think about that in every rotation, how much distance does the smaller disk travel? Okay, so can I say for every rotation of the smaller disk, distance traveled, distance traveled is equal to 2 pi times small a. Now you realize that since the overall distance traveled is 5 times this, I hope you realize, since the overall distance is 5 times this. So in one revolution of the assembly, the disk would have rotated 5 times. You guys agree? So therefore, in one rotation, revolution of the assembly, the disk rotate 5 times. Okay. So if the time period of revolution of the disk is t, then the total time taken for one revolution is 5 times t, right? Therefore, if time taken for one rotation of disk equals time for one revolution, time for one revolution What will that be? That will be equal to 5t. Okay. And therefore, and this will be 2 pi over omega, correct? And therefore, omega dash, the angular velocity of the, let's call that omega dash, the angular velocity with which this entire assembly is rotating about this z axis, how much will that be? Omega dash would be 1 over, or I can say that 5t will be equal to 2 pi over omega dash. This is essentially, I'm saying that 2 pi over omega to 5 equal to 2 pi over omega dash. So firstly, I'm getting omega dash equals omega by 5. Okay, this should be easy to see. Okay, I hope there is no confusion about this. So let's go through this. First, finding the omega dash. That is very simple. So you can think that every time this revolution is happening, okay, every time this assembly goes from here and covers till here, the bottommost point which is touching it has moved in a circle of x radius, right? So it has covered a distance of 2 pi x. Now in one rotation of the disk, it would have covered a distance of 2 pi a, and since x is equal to 5, it is traveling in a 5 times the radius. So it will, so for every 5 rotations of the disk, one revolution would be completed. So the angular frequency of revolutions would be 1/5 of the angular frequency of rotation of the disk. Okay, I hope you realize that. Let me know if you followed this, and then we will move on to the next part of this solution. Okay, if you followed this, then let me know. So take a look at this and let me know if you followed this. If there is any confusion, you can let me know. Now we will move to the more tricky part. Okay, what I'm getting is my option A is correct. Option A is correct. All right. Now, the second part says the magnitude of angular momentum of the center of mass of the assembly about the point O is 81 ma square omega. So how do you find that? Let's see. So first we need to locate the CM. Okay, so first we will try to locate the CM. Ouch, I should have left more pages here. Okay, so maybe we'll add one more page here. We'll definitely need more pages for this. Okay, so let's try and find out the angular momentum of the CM. Okay, of the CM about this. So once I know that this is the situation, imagine we knew that this was the situation. Now, first we'll find the center of mass. Okay, so you know the center of mass of these two disks would lie on the line joining them, right? So the center of mass would be lying somewhere here, closer to the 4m disk. So this disk has a mass of 4m. This guy has a mass of m. You know the line joining the center of mass divides divides this the center of mass divides this line in inverse ratio of the masses. It divides this is inverse ratio of this masses. So can I say that this length would be in fact 4 by 5l, 4 by 5l, correct? Why? Because this entire length was l. Okay, so pay attention. This entire length was l. This length was also supposed to be l. They may not look equal right now, but that is what was given. Okay, so let's pay attention. Let's take a look at this figure. So what I'm saying is that the CM would have lied somewhere here, and since this was 4m, this was m. So line join the CM divides the line joining two masses in inverse ratio of the masses. So this length I can say would have been 4L by 5, and this would have been L by 5. So then the ratio is 4:1, correct? Now that I know this, how do you calculate the angular momentum of any object with respect to a point? Let's talk about that also. So first of all, let's talk about the velocity of the CM. Let's talk about the velocity of the CM. So what will be the velocity of the CM? Let's also talk about that. So can I say that this entire assembly, we just realized it's rotating about this with omega dash and rotating about this with omega. Okay. So what will be the okay, so omega dash is not visible to you, right? So can I say that this has an omega dash angular velocity here? So what will be the velocity of the CM? So velocity of the CM would be this length, let's call that x dash times omega dash, correct? In that direction. So let's draw ourselves some axes, because for angular momentum, I need my axes, I need my coordinate system. So let's imagine this is y, this is x, and this is z. Now, can I say that the instantaneous velocity of center of mass, what will that be? So velocity of center of mass, VCM vector, would be omega dash x dash minus k cap. Please note that this will be the velocity of the CM. Okay, think about this. This entire assembly is rotating. So the CM is rotating with a constant velocity. Correct? It is rotating with a constant velocity. Okay. So omega dash I already know is omega by 5. What about x dash? Can I calculate x dash? Yes, I can. X dash is nothing but this. So this is x dash. And if I know this theta, I know this theta. This is 90. So let's take a look at this triangle. Let us take a look at this triangle. So in this triangle, can I say x dash equals that length? That will be 9L by 5 cos of theta. So from this triangle, from the highlighted triangle, you will notice that x dash equals, that will be 9L over 5 times cos of theta, right? And this triangle, let me also tell you that we already discovered some things about this theta. This triangle, if this was theta, you realize this was 5a, okay, x we had already calculated. This was 5a, this I know is a, this is 90. So from here, what is cos theta? I can say cos theta was root 24 by 5, and sine theta was 1 over 5. And tan theta also you can find out now. So from this triangle, I will substitute the value of cos theta, and let's see what we have here. So I am getting that this is equal to 9 times cos theta was actually L by, yeah, it was root 24 by just L times root 24 over 25. Okay. So now let's just substitute the value of L also. L was root 24a. So this x dash becomes 9 into 24 over 25a. Correct? And omega, how much was omega dash? Omega dash we already calculated was omega by 5. So VCM vector now I can write. VCM vector now becomes this entire thing multiplied together. Okay, so let me use the calculator. Okay, so this is a very, very tricky question. I'll solve slowly and you guys try to follow what I'm doing. And I'll show you the error that is there in all the solutions available in on YouTube. What is the error that they have made? This is coming out to be 216 over 25 into 5, that is 125. yeah, over 125, and a omega a, and I am having minus k dash, minus k cap. So this is what VCM vector looks like. Now that I have found VCM vector, let's write the position vector of CM with respect to O. So this is O, this is CM. So if I can find the position vector of O with respect to CM now, then I can find the angular momentum of CM with respect to O. So let's write this position vector. So what will this position vector be? This position vector would be, can I say R of CM with respect to O would be written as 9L over 5 times cos of theta I cap plus sine of theta j cap. Correct? Now I know angular momentum of CM with respect to O is nothing but R of CM with respect to O cross VCM times M times the total mass, which is 5M. Okay, I hope you remember this. This is how you calculate the angular momentum of a point mass about a fixed point. So CM is essentially a point mass. So for finding the angular momentum of point mass, all you need to do is M R cross MV, right? So M I have taken out, and this is what I have. Try and calculate this. So when I do this, so I will take out. Let's take out these things. So this you realize is already getting very big. The term is getting very big and weird. What I'm getting is, let's see what I'm getting. Oh, so I will get. So let's take everything out. I have 216 over 125 into omega a into 9L by 5, and then I have cos theta of I cross, so that is I cross k would have been minus j, and I have a minus sign here, so I would have had cos theta j cap, and then I would have had j cross k. So j cross k would have been I, but then minus I, sine theta I cap. Okay, so this is what I am getting. This is what I am getting this as. So angular momentum of CM with respect to O, that would be 9 into 216. Okay, so that is let's try and sort this out. 216 into 9, which is 1944 over 625 into root 24 omega a square times cos theta j cap minus sine theta I cap. So you realize this is the magnitude. We talked about the magnitude. This is the magnitude. Of course, this is not 81. Of course, this is not 81. Okay. This is nowhere close to 81, in fact. Okay. Maybe this might be close to 81, by the way. So, but now it is slightly less than it is slightly less than 77. So I'll tell you what this is. I'll tell you. I'll calculate the exact value of this, and I'll tell you. Let's see. Let's use the calculator. Okay. I hope I have calculated everything correctly. Yeah, seems correct. So it is in fact coming out to be the mod of this comes out to be some 15.2, okay, omega a square. I'm not sure though. I may have missed a 5 somewhere. Let's can check it because I remember once I tried, it was around 76. I may have had a 5 extra somewhere. Anyhow, so that's the difficulty with this kind of question. Okay. Oh yeah, oh yeah, oh yeah. So this was okay. No, no, this is correct. Correct. Hmm. So this is what I'm getting. Definitely not 81, root 81. So this answer is wrong. Okay. This answer is definitely wrong. Now comes the tricky part. Now comes the tricky part. The option C that says the magnitude of angular momentum of the assembly about its CM is this. So this is where most of the people went wrong. Wherever you see the solution, they have given this answer of this wrong. And that is why IIT says if you mark A, then that is definitely correct. A or A and C. They have even given A or C as correct. Why they have done this? I'll tell you why. Now, when you go to the reference frame of the CM, let's see what you will see. What do you think you will realize? So try and analyze the motion of this. Okay, so I'll tell you what people have missed. So you've been told the magnitude of angular momentum of the assembly about its center of mass. So how do you calculate that? You go into the reference frame of center of mass. So imagine I am in the reference frame of the center of mass. Imagine that I am here in the reference frame of the center of mass. Now the center of mass becomes stationary. Okay. Now what do I see from this reference frame? I will see the entire assembly rotating like this, which is fine. Now I see another rotation. I will see another rotation which everybody has missed on YouTube. I will also see the entire assembly rotating about this axis. I hope you realize that. I will notice the entire assembly to be rotating about this axis as well. Why? Imagine when this is happening. Now let's come to the CM. In the reference frame of the CM, this end, the bigger disk, is to the right now, right? So when you are rotating, you realize when it has come from here to here. Now, with respect to the CM, this has come towards left. Okay, this has come towards left. So if you move from here to here, then you realize that this kind of rotation is also happening. In the reference frame of the CM, your entire assembly is rotating like this. I hope you realize. What most people have gotten wrong in YouTube is that they have missed out on this. They have missed out on this angular velocity. I hope now you can visualize. Can you? Can you visualize this? Now the point is you can have two sorts of reference frames fixed to CM. Now you can have a rotating reference frame fixed to the CM in which you wouldn't have seen this, or you could have had a translating reference frame in which you would have seen this. That is why A and C are both correct. Okay, now the reason IIT should not have asked you this question because of two reasons. First, multiple omega systems are not in your syllabus. Multiple omega systems are not in syllabus. So it is very unlikely that IITs will ask this again. Sir, is this kind of problem likely to come in the advanced papers? No, absolutely not. It was a flaw. They shouldn't have asked this question in the first place because this system has two omegas. Your in your syllabus, you only have single omega systems. This has two omegas. You realize the entire assembly has two omegas about in the reference frame of the CM. I hope you realize this, that this has been ignored by a lot of people. Shorts guy, can you see this? In TB solution, TB did not pay attention to this rotation. When you are in the reference frame of the CM, you will see this rotation also. So you have to add angular momentum of this also. Okay. Can you figure this out? Do you agree that not only will you see this rotation, you will see this rotation, but you will also see this rotation in the reference frame of the CM, which a lot of people have ignored. And that is why the answer was A and or A and C. Somebody could have argued that okay, I have a rotating reference frame fixed to CM. So if you have a rotating reference frame fixed to CM, then you won't see this velocity probably. But again, rotating reference frames are not in your syllabus. Also, rotating reference frames are not in your syllabus. Okay, so in your syllabus, you only have translating reference frames. What am I saying by that? What I'm saying is that whenever you move into a reference frame, now even if this guy is moving in a circle, your axis is never rotate. That is the translating reference frame. This is a translating reference frame. That even if in a circle, your axis is moving like this is a rotating reference frame. When you're moving in a circle and your axes are also rotating, that is a rotating reference frame which is not in your syllabus. So if you had a rotating reference frame fixed to the CM, then you would not have seen this omega. Then you would have gotten that answer C. But in our reference frame, whenever we go into a reference frame, we go into a translatory reference frame. In translatory reference frame, I would have seen this omega also. And that is why even if you did not pay attention to this omega, they have still given this as correct. Because theoretically you can argue that maybe my reference frame was rotating. If you were in a rotating reference frame about the CM, then you would have gotten C. But according to JEE, you should have been in a translating reference frame where you would have had an additional term like this. Okay. So that is what will happen. The magnitude of angular momentum in the assembly. So let's talk about the part C now, if you want to really. Are you up for it? Are you up for it? Looking at the part C. Now this just keeps getting difficult and difficult. So as I said, now the issue is so best advice would have been if you saw such a question, that's all right. That's all right. I don't like to blame people. It's okay. It's okay if she missed something. It's okay. I think it still took a lot of effort, no, to even attempt to solve this question and put it up on YouTube. I think it takes a lot of courage. Let's appreciate the effort, and I'm sure it was an unintentional mistake, right? I'm sure it was an unintentional mistake. The mistake was not made intentionally. Just probably did not visualize the problem good enough, right? So that is all right. So there is a difference, no? See, that is the reason why I cracked the IIT JEE and TP didn't. Okay, so that's the difference. That is the difference, and that difference always remains. That is why I had cracked the IIT JEE and TP didn't. Okay, because I do not miss things. So in the reference frame of the CM, now you have two omegas. One, you have this omega, and then you have this omega. So you have to take the angular momentums due to both. Okay, omega by 5 like this in the reference frame of the CM. Okay, and now obviously if the angular momentum due to omega is L1 and angular momentum due to omega by 5 is L2, so then you need to calculate those. Let the angular momentum due to, so you have two motions that you see in the reference frame of the CM. You see a rotation like this and you see a rotation like this. Correct? Correct. So there will be one angular momentum from the reference frame of CM due to this omega and one due to this omega. So let L be let the angular momentum due to omega, this kind of rotation, omega be L1 vector, and due to omega by 5 be L2 vector. So now now you can apply. The TVS has a degree majoring in astrophysics and mathematics. So that's all right. That's all right. So trust me. JEE has another level. So there is a reason why JEE is considered to be one of the toughest question papers in the world. Okay, don't worry. And there is a lot that you don't know about me. So though I did not go to major in astrophysics and maths, Okay, there are things that I can tell you about myself which will shock you. Okay. All right. Anyhow, let's not get into that. This is the correct solution. That is what I want to tell you. This rotation was missed by TB. Of course, unintentionally. Okay. So L1 vector would have been equal to the angular momentum about this axis. So let's call this axis number one. Let's call this axis number two. So L1 would have been I about axis number one times omega, and obviously along this direction. Okay, where this would have been the direction of omega vector, and omega by 5 vector would have pointed in this direction. So let's try and calculate I1. So this is very easy. This is nothing. I know this is okay. So what is this? What is this? This is nothing but this is ma square by 2, ma square by 2 plus 4m into 2a square by 2 times omega vector. So obviously this, when you calculate, you will realize this is ma square omega vector times you have 1 by 2 plus 8. So obviously that is 17 by 2 ma square omega vector. Right. So the magnitude of this is definitely 17 by 2 ma square omega, which is fine. Which is fine. But this is not all the angular momentum. Now you also had the term L2. What would have L2 been? Now L2 would have been difficult to find. L2, for L2, what you would have done is you would have found this, let's call this x2, and let's call this, so yeah, let's call this x2. So the cm would lie here, cm would lie here. Let's call this x1. So for finding out L2 would have been both the disks now are performing this kind of a motion. So they are not rotating, so they can be treated as point masses at their center of masses. Okay, so L2 would have been equal to m times x1 square plus 4m times x2 square times omega by 5, and this would have been j cap. Okay, so this is another term that you would have added. Okay, you should have added this L2. This kind of angular momentum would also be present. Okay, along with this angular momentums. That is why, even if you mark this, then IIT just gave you marks. Okay, but this is not entirely correct, and that is why, according to me, the answer is only A. But I think IIT wanted people to give them credit. If they could calculate L1 also, because they also probably realize that a lot of you will not realize about L2. Okay, why? Because this is not in your syllabus, right? Multiple omega systems are not in your syllabus. So this is easy to see. L1 angular momentum is very easy to see. L2 angular momentum is not easy to see. A lot of people will miss this rotation, which has been the case. So that is why they have still given answer. The reason why they have given answer is because they asked something wrong. They shouldn't have asked this question in the first place. The only correct answer is A only, by the way. So actually speaking, C is wrong. C is only partially correct. Okay, only one part of the angular momentum is there in option number C. And then, of course, if you solve it further, then you will realize that this would be wrong. Okay, so this would come out to be wrong. And how do you calculate this, by the way? So let me just quickly tell you how you would have calculated this. Okay, for part number option D, you will realize that the angular momentum of the entire assembly about O. So how do you calculate that? You should know that angular momentum of any system about O should have been equal to angular momentum of Cm about O plus the angular momentum of system about Cm. So what you realize is that in the previous parts, this that you calculated here, let's write it, and let's call this L0. Let's call this L0 vector. Okay. Now you would have realized that the net angular momentum would have been the sum of all the three things that you calculated above. Okay. So you should have realized that L of system, so L vector, would have been equal to LO vector plus L1 vector plus L2 vector. So this is how you would have calculated the answer finally. Okay, hello Shivansh Ranjan. Yes, you are pretty late. In fact, I am done with today's discussion. It already took very long. So this is how you would have found the option for answer D. The magnitude of angular momentum. So first you would have calculated this, and then you would have taken all the okay. So this is their z-axis. So in our case, I took this as the y-axis. So you would have taken all the j components. First, you would have found this. Then the j components of this would have been the answer, right? J cap component would have been the answer. So this is the correct solution of this problem. Try to go through this problem one more time. If you have any doubt regarding this, let me know. Let me know. Leave your thoughts in the comment section. I will take up this problem again in the next lecture if you guys want. Okay, this is one of the toughest problems. Again, as I said, most of the solutions given on YouTube are wrong about this. So they have missed out on one term. So go through it and let me know if you're convinced with what I have to say. Okay, and let me know your thoughts. And then in the next class, what I will do is there is one more question that I really wanted to discuss, which was this is one very interesting problem. Again, here also two options with or were given. Okay, so why was that? We need to think about that. And then of course is this problem, which I think was another highly controversial problem. None of the coachings actually figured this out. All the coachings gave one correct answer where there was no correct answer for this. So IITs also make mistakes. They have asked questions for which no correct option was given. Okay, so yeah, this is another interesting question. This I would like to discuss. So we will continue this discussion in the next class. Don't worry because this discussions deserves some more time. That is why I probably extended my session by 20 minutes today. Anyhow, let's just wrap it up for today. I'm sure you guys are feeling highly exhausted by looking at all the answers that I've calculated for the question that we just discussed. Just go through that solution like 2 3 times. Think about this, and try to figure out if you follow it. Now, my advice: if IIT asks such a question, you should have just left it. You should have just left it because that kind of question, which has two omegas. See, multiple omega systems are not in my syllabus, not in my JEE syllabus. So I know analysis of multiple omega systems is going to be highly difficult. I would rather leave that question than even attempt it. Okay. Though I know how to analyze multiple omega systems, but you guys are not used to, so you are bound to make mistakes. Okay, and trust me, it's not worth it. That question was definitely not worth the time you would have to spend. Okay. All right. So with that, I'd like to take your leave and I'd like to wrap up this session. Before I go, let me remind you that you should be getting your Plus subscriptions as soon as possible. And this is how you do it. You go to the Plus section of your app, you select your goal as IITJ, click on that Get Subscription button. Now, when redirected to the payment page, use the code RDLive to receive 10% off on all your subscription fees. Now, you have two options of getting your subscriptions. You can either get the Plus subscription now or the Iconic subscription. These are the fees of all the subscriptions after the discount, a 10% discount, which you get after applying this code. Now, then you can click on proceed to payment. Okay, and when you do that, you will also have a lot of no-cost EMI options to choose with. So go get yourselves the subscription. And now you can also choose the Iconic subscription, right? So this subscription takes your JEE preparation to the next level by you will be allotted personal coaches here. Okay, you will be getting a lot of IIT JEE workshops, expert guidelines, study planner, and test analysis sessions. Okay, so with the help of these features, your JEE preparation would propel and go to the next level. So if you want that, then go for it. And then of course, if you like today's video, please go through today's video very carefully, very carefully, because the problem that I discussed today was one of the most complicated problems that you will ever see. Because see, that is already something that is out of your syllabus. Should not have been asked. That question should not have been asked. Like it's like analyzing the rotation and revolution of Earth. Okay, so that is not in your syllabus. Okay. Now, if you still like today's discussion, and if at least I could get you some clarity about how you would have approached that problem, don't forget to press the like button and share this with as many people as you can, so that more and more people get to know the correct solution. If you're new to this channel, don't forget to subscribe. Click that subscribe button and subscribe for regularly watching more and more amazing videos like this. And don't forget to press the bell icon to keep on receiving the notifications. And the PDF of all these slides used in today's lecture would be available for download very, very soon. Now, those of you following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that again you are not missing out on any of the lectures or sessions happening here. One last time, this is my code RD Live, so you can use this code to get your Unacademy subscription. Next, if you like my lectures, if you'd like to enroll in my courses, use this code and get your Unacademy subscription and join me on Unacademy Plus. So I'll see you next day after tomorrow. Till then, you guys go through that solution. Leave any thoughts that you have in the comment section. Make sure you are attending the next session live and getting all your doubts cleared. Okay. See you next. Till then, you guys keep studying.